Hi and welcome to the Incite My Life channel. Today we're going to be going over the essentials of Exam P with regards to the geometric distribution. So before we get started, let's take a look at some of the key properties of the geometric distribution. The first thing that you want to note is to make sure that the trials are independent of each other. And the second thing is that the probability of success is the same per trial. So let's take a look at what the formula is. So you notice that it's 1 minus p to the power of k times p. So p represents our success rate. So what this equation is saying is you're having successive failures before the first success. So in verbal form, it's the probability that x is the number of failures before the first success. So let's take an example of this. Let's say I had 4 failures and 1 success. So if I was going to put that into an equation, I would say whatever probability the failures were to the 4th power, because you notice there are 4 failures, and then the probability of success on the outside of that. So let's take a sample question. Let's say you have a slot machine at the Everybody Wins casino that has been measured to have a success rate of approximately 1%. What is the probability that someone wins after 1 standard deviation more than the expected number of failure that it takes to win? So the first thing we want to establish is that x is our number of failures before the first win. So this question is asking for standard deviation and expected value, so you want to make sure that you memorize those formulas for expected value and variance. Because when you actually go and take the Exam P test, you don't want to waste any time trying to derive the formulas. So make sure that you have these fully memorized. So the expected value of x is 1 minus the success rate over the success rate. So the success rate, 1%, is 0.01, and you can see that the expected number of failures before the first win would be 99. And so the variance formula, very similar to this, is 1 minus the success rate over the success rate squared. So you can see that the variance is 9,900. So the standard deviation then is just the square root of the variance, which comes out to be about 100. So it says, what is the probability that someone wins after 1 standard deviation more than the expected number of failures? So the standard deviation is 100 and the expected value is 99. So putting them together, we're finding where's the probability that x is 199. So if it's 199, then we're going to have the failure rate to the 199th power, because remember that's how many failures we're expecting, and then the success rate on the end. So it comes out to be 0.001. All right, now the moment we've been waiting for. Let's take an SOA sample question in its intensity. So the same thing, but we're going to change a few things about this. A slot machine at the Everybody Wins casino has been measured to have a success rate of approximately 0.01%. What is the absolute difference between the 95th percentile of losses before the first win and the expected amount of losses before the first win? So take a jab at this one, try and work it out on your own, but I'm going to begin the answer right now. So the first thing we want to know is the probability of losing. So it's the complement of the probability of winning, which is going to be 0.9999. Now the percentile. So think of it as a cumulative, I can't even say that, a cumulative distribution. So it's some value where everything less than or equal to that value is going to be 95%. So in order to think of what that might be, we have to count up the probabilities up to what will equal 95%. So if I was to put that out in written form, so on your papers you would say, okay, 0.999 to the 0 power, so you nail it in the first try. Okay, you miss it in the first try and get it on the second try, and you repeat that process up until you have 0.999k times 0.001. So that 0.99k represents the the number that we're looking for. K is the number of failures that it's going to take to put us in the 95th percentile. So you notice the progression of this is following a geometric distribution. So if we pull out some factors here, and then we look at it as a finite sum of a geometric series, then we can just apply that formula. So by pulling out the 0.0001, then applying the finite sum of a geometric series formula, we can equate it to this. Now it's going to be pretty easy to just solve for k, which we will get to be about 29,956. And then going back and applying our expected value formula, where it's 1 minus the success rate over the success rate, is about 9,999. So the absolute difference between these is just the first minus the second, which comes out to be about 19,957. So thank you guys so much for watching. Please take the time to like and subscribe to my channel, and I'm going to keep putting out more on the Exam P Essentials. So stay tuned, guys. Thank you so much. See you next time.